Today, I am diving into a wild experiment where I try to imagine what would really happen if kilonova radiation hit Earth-led SC if I can handle the science. Imagine this. A pair of stars collide in a far-off galaxy. The light travels for millions of years until one day it arrives in our solar system. But along with the light comes something far more dangerous. Invisible waves of deadly radiation. What would happen to Earth if kilonova radiation reached us? A kilonova is born when two neutron stars collide. These objects are so dense that a teaspoon of neutron star material weighs as much as a mountain. When they crash, the explosion is so bright it can outshine an entire galaxy. But the real danger isn't just the light, it's the burst of high-energy radiation. Imagine a cosmic explosion so powerful that it S like a supernova on steroids. That S. Basically what a kilonova is. These events are among the most energetic in the universe, often occurring when two neutron stars collide. The significance of kilonovas in the cosmos can't be overstated. They're like cosmic lighthouses, helping us understand the most extreme environments out there. Kilonovas unleash floods of gamma rays, X-rays, and neutrinos. The most dangerous are gamma ray bursts, focused beams that can travel billions of light. If Earth was ever caught in the direct path of one, the results would be catastrophic. Kilonova radiation is different from other cosmic events like solar flares or even regular supernova. For one, the radiation it emits is not just limited to light. We're talking gamma rays, X, and all sorts of high-energy particles that could potentially wreak havoc on our planet. If kilonova radiation were to hit Earth, the possible effects could range from damaging our atmosphere to interfering with our technology. The very fabric of our ecosystem could be at risk. The impact on satellite communications and even the power grids could be severe. Our daily lives could grind to a halt if we're not prepared. As the radiation enters our solar system, the first victims wouldn't be humans. Outer satellites, spacecraft, and planetary probes would be fried instantly. Even distant planets like Neptune would be bathed in deadly radiation long before Earth even noticed. Our cosmic neighborhood would light up with chaos. To understand kilonovas, let's dive into their formation. These events are thought to occur when two neutron stars, which are incredibly dense celestial bodies, collide. This collision releases an enormous amount of energy across the electromagnetic spectrum. Historically, we've seen similar cosmic events like gamma ray bursts, which have been observed to affect the environment around them. For instance, some scientists believe that a gamma ray burst could have contributed to the mass extinction event that occurred about 450 million years ago. To understand kilonovas, let's dive into their formation. These events are thought to occur when two neutron stars, which are incredibly dense celestial bodies, collide. This collision releases an enormous amount of energy across the electromagnetic spectrum. Historically, we've seen similar cosmic events like gamma ray bursts, which have been observed to affect the environment around them. For instance, some scientists believe that a gamma ray burst could have contributed to the mass extinction event that occurred about 450 million years ago. Within seconds, Earth's magnetosphere, our first shield, would be slammed by the incoming blast. The auroras would explode across the sky in colors never seen before. But this dazzling light show would mark the beginning of a catastrophe. If kilonova radiation were to hit Earth, the immediate effects would likely be catastrophic. The high-energy radiation could strip away parts of our atmosphere, exposing us to even more harmful solar radiation. Long-term effects could include disruptions to our climate patterns and potentially even altering the course of even the impact on our technology could be just as severe, with the potential for widespread power outages and communication disruptions. The very thought of it sends shivers down my spine. The radiation would shred Earth's ozone layer, our invisible shield against harmful ultraviolet rays. Without it, the sun's UV light would pour down, sterilizing crops, damaging skin, and devastating the food chain. A single intense burst could trigger a mass extinction event. For humanity, the first hours might feel like nothing more than a strange light in the sky, but soon, satellites would fail. GPS would collapse, and communication networks would vanish. Imagine waking up to a world where planes can't navigate, phones don't work, and cities fall silent. Within weeks, radiation sickness could spread, crops would fail, livestock would weaken, and freshwater supplies could become contaminated. Governments would scramble to move people underground, but only a fraction of humanity could survive long-term in bunkers. Long after the initial blast, Earth would be locked in a different kind of disaster. Increased UV radiation would disrupt ecosystems for decades. Ocean plankton, the foundation of the marine food web, would die off, sending ripple effects all the way to humans. Life might adapt, but our civilization would never look the same. Here's the good news. Kilonova radiation powerful enough to threaten Earth is rare. Astronomers believe they happen once every 100,000 years in a galaxy. Even then, the radiation is beamed in narrow jets, so Earth would need to be perfectly in the crosshairs. The odds, tiny, but not zero. What if we had a warning? With enough preparation, we could design space shields, redirect satellites, or build vast underground cities. A kilonova threat might actually push humanity into a golden age of technological innovation survival, forcing us to evolve. So, what if kilonova radiation reached our solar system? It would mean chaos, collapse, and possibly extinction. But also a reminder of our place in the universe. We are fragile, yet resilient. And every time we look up at the stars, we're reminded the universe creates, destroys, and challenges us. But it also dares us to survive. In conclusion, understanding kilonova radiation and its potential impact on Earth is crucial. These cosmic phenomena remind us of how small we are in the grand scheme of things, and how important it is to stay informed about the universe and its many mysteries. So, what do you guys think? Would you be able to survive a kilonova radiation event? Share your thoughts in the comments below. And if you're interested in more cosmic adventures, be sure to check out my other videos on space and astronomy.